So when you are given an expansion, let's say of this type, a plus b to the power n, like that, and then they ask you to find the rth term, or find the r plus 1 term. So r plus 1 term is equals to r plus 1 term. This is equals to n choose. This part here is going to follow from this. What you have here, since it's r plus 1, so this is going to be r plus 1 always minus 1, so that you have r. So this is going to be r like that, and then this a is just, it will take its position, and then it is a to the power n minus r, and then b to the power r, like that. So this is the formula that you use when you are asked to find a particular, it's just a specific term in a given expansion. So let's say for example you have you have x plus 2 to the power 8, and I want you to find the fourth term. So I want you to find the fourth term. So in order to find the fourth term here, you got your formula to say fourth term is T4, and this is equals to n choose 4, but here your n is equals to 8, so it is 8 choose. So now since it's fourth term, here it will be 8 choose 3, it is 4 minus 1, so this is going to be 3, and then x, which is the first term, 8 minus 3, and then 2 to the power 3, and this is equals to 8 choose 3 x to the power 8 minus 3, which is 5, and then 2 to the power 3, which is equals to 8, like that. So 8 choose 3, use binomial or the factorial notation. So this is going to be 8 factorial over 3 factorial, next 8 minus 3, which is 5 factorial. So we can expand 8 factorial here up to 5 factorials, which is 8 times 7 times 6 times 5 factorial over 3 factorial is 3 times 2 times 1, and then we multiply by 5 factorial. I'm not going to expand this because I have it there up. So here, when you look at what we have here, what we have remained with here is 3 times 2 times 1 times 1, which is 6. So this 6 and that 6 cancels, so you end up remaining with the 8 times 7, which is equals to 56. So in short, 8 choose 3 is equals to 56. So 56 multiplied by this 8 that you're seeing here, you end up getting 448 here, and this is equals to x 5. So you conclude, say therefore the fourth term is equals to 448 x to the power 5. So that is our fourth term. Let's move to another example. Let's look at this, which is b. So we are given 2x minus y to the power 12. 2x minus y to the power 12, and they want us to find a specific term, which is the seventh term. So to find the seventh term, you say seventh term, which is t7, is equals to n choose, but here the highest value here, the value of n is 12, so it is 12, and then 7 here, it will be 7 minus 1, which is 6, and 2x is our first, this is our first term, and that's our second term. 2x to the power 12 minus 6, which is 6, open brackets, negative y, don't forget the negative, to the power 6, like that. So you can start our expansion here. So when you look at 2 to the power 6, what is the value for 2 to the power 6? 2 power 6, we have 64. So this piece here, I'll maintain it first before expanding it. So the answer here is 64 x to the power 6 multiplied by negative y here to the power 6. 6 is an even number, so the outcome here will be positive. So this is y to the power 6, like that. So all we need to do is to find what is 12, choose 6. What is 12, choose 6. So here we have 900. The answer for this is 924. So you can confirm this by saying 12 factorial divided by 6 factorial, and next 12 minus 6, which is 6 factorial, like this. So what are we going to have here? So 12 factorial, just a minute, sometimes let me just expand this. 12 factorial is 12 times 11 times 10 times 9 times 8 times 7 times 6. Since I have 6 factorial down there, I'll end at 6 factorial. And the other 6 factorial, I can expand it, times 5 times 4 times 3 times 2 times 1 times the other 6 factorial. So this other 6 factorial and that can cancel. So your task is to find the value of this top part here, divide by this. So when you do that, you end up with 924. That's what you end up getting. So this 924 is what we are expected to write here. So 924 multiplied by 64 multiplied by x6 and y6. So 9 times 64, the answer is 59,136 x6 y to the power 6. So what we have here is our 7th term. So the term independent of x, let's suppose we have, let me add this. For example, you have this question here. You have 1 plus x to the power 3. Let me just do this. When we expand this, this is going to be 3 choose 0 to the power 1, 1 to the power 3, plus 3 choose 1, 1 to the power 2, x to the power 1, plus 3 choose 2, 1 to the power 1, and then x to the power 2, plus 3 choose 3, and we have 1 to the power 0, x to the power 3. So in short, here we have 3 choose 0. Please, if you remember your Pascal's triangle very well, 3 choose 0 is equals to 1 3 3 3. So 3 choose 0 here, it's 1. So 1 multiplied by 1 to the power 3, it's 1, plus 3 choose 1, the answer here is 3. 3 multiplied by 1x, the answer is 3x. And then 3 choose 2, the answer is 3. 3 multiplied by x squared, you have 3x squared. And lastly, 3 choose 3 is 1. Multiplied by x3, you have x3, like that. So this is what we have. So if at all a question arises and say find the term independent of x. So the term independent of x here, when you look at all the terms that we have this term here, we have this term here, we have this term here, we have this. So when you look at all these terms, it's only this first term here. That is the only term that is independent of. This is the only term that is independent of x. All these have got what? They've got x in them. So now how do we find this term that is independent of x? So now to find the term independent of x, you since we don't know that term, so you start by saying let t r plus 1 be the term independent, be the term independent of x. That's how you start. So let t r plus 1 be that term which is independent of x. So you write t r plus 1 and you start your definition. Say for t r plus 1, this is equals to n. Choose whenever you have r plus 1 here, it is always the r plus 1 minus 1. So it's r here, and you have a to the power n minus r and b to the power r like this. So this is equals to, you start replacing using this question that we have above. The value of n is 3. So where there is n, you put 3. The value of r here is not known, so you leave it as r as it is appearing. The value of a is the first term, which is 1. So you put a 1 here, and then 3 minus r like that. Next, b is equals to x to the power r. That's what we have. So now our task is to solve this part which is here. So let me open another page. So you have t r plus 1 is equals to 3, choose r, 1 to the power 3 minus r, and then x to the power let me see if I thought that's what we had. Okay, 1. Okay, great. So this is what we have here now. So now after this part is done, the next thing that you need to do is, since you are talking of the term independent of x, so a term that is independent of x has got x, but the x that it has is to the power what? 0. Because if we are to go back to this question that we have here, this is the term that we are looking for, which is the one which is independent of x. So 1 multiplied by x to the power 0. This x to the power 0 is going to give us 1. So this is it, the term independent of x is that term that has got x which is raised to the power 0. So whenever we talk of the term independent of x, I want you to not say it is that term whose highest power of x is 0. So now if that is the case, we do the same here. After you have simplified, after you have reached at this stage, please arrange all the terms that have x in them. After you have arranged all the terms that have got x in them, and then equate this term that has got x to 0, because you're talking of the term independent of what? Of x. So you equate this to x power 0. And then when you do this, you have r here is equals to 0. So when r is equals to 0, you go back to your function. So it is t 0 plus 1, so it is 1. And this is equals to 3, choose 0, and then 1 to the power 3 minus 0, x to the power 0 like this. So when we simplify this, 3 choose 0 is 1. 1 to the power 3 is still give us, it gives us a 1. And x to the power 0, it's 1. And this is what we have. So the first term, which is t1 here, is equals to 1. So the first term here, and it's equals to this one, is the term that is independent of x. So this is how we find the term independent of x. So if we are to go back, this is what we got. We got the value is 1, but the term here is what? T1. It's position 1. So let's look at another example. Find the term independent of x in this expansion. X minus 1 over 2x to the power 20. So how do we find the term independent? Meaning that the term here that has got the value of x which is raised to the power 0. That's what we are looking for. So we'll start by saying let tr plus 1 be the term independent of x. Be the term independent of x. Therefore tr plus 1 is equals to 20, the highest value here, to the power what? Here, shouldn't forget, whatever you write here, if you are saying r plus 1, meaning that here it will be r plus 1 minus 1, which is r here. If you are using tr here, just not to say here, it will be 20 r minus 1. That's what you are expected to have here. So be careful with what you write here. It has to be a minus 1 at the end of the day. And then next, it is x here, and this x is to the power 20 minus r. The next term, just a minute Clement, let me write this, negative 1 over 2x, and everything that you have is to the power r like this. So now after this part here, you have to make sure that all the parts that contains x, you need to group them together. You need to group all the parts that contains x. So here we have 20, choose r, and this is x to the power 20 minus r, and this part here we have negative 1 times 1 over 2x, and everything here is to the power r like this. I want you to get it from this angle. So meaning that here you are going to have negative 1, which is going to be to the power r. The next term that you have is 1 over 2x, but remember you're going to have 1 over 2x, and this part which is here, this one, which 1 over 2x, so 1 over 2x here, 1 over 2x is the same as 2x to the power negative 1. I want you to understand that. So this is the same as 2x, everything to the power negative 1, and this part is raised to the power r like that. I'm doing all this so that all the parts that contains x are put together. So negative 1, I can write it here at the beginning, and then x to the power 20 minus r, and here when you have 2x to the power negative r, I can factor out 2 because I just want to have x. So I can say this is 2 to the power negative r, and we have x to the power negative r like that. So all the parts that have x, let's put them together, and this is going to be negative 1 to the power r, 2 to the power negative r, and this part here we have x 20 minus r, and then this part here it is x to the power negative r like this. So this part contains x, we have to group this together. So regrouping this together gives us so t r plus 1 is equals to 20 r, we have negative 1 here to the power r, and 2 to the power negative r, and we have x to the power what? Let me see what we got here. X to the power 20 minus r, x to the power 20 minus r, and this other x to the power, this other x is x to the power negative, x to the power negative r. So x to the power negative r. So this part, let's simplify this part together. So same bases, what do we do to the powers? We add. So when we add the powers here, we'll have 20 minus r plus minus r here. So the end result for this first piece, it will be this negative 1 to the power r, 2 to the power negative r, x to the power 20 minus 2 r, like this. So the moment you reach at this stage where all the terms for x are put together, you now get this piece here. Since we are talking of the term independent of x, meaning that x is raised to the power 0, and this is equals to x 20 minus 2 r, like this. So you solve this equation and you have 20 minus 2 r is equals, when you have these, they will cancel 0, and then 20 is equals to 2r over 2 over 2. So this implies that the value of r in this case is equals to 10. So since the value of r is equals to 10, we get back to our function here. Here, where there is r, I put a 10. So it will be 10 plus 1, which is 11. And this is going to be 20, choose 11, or 20, choose 10 here, and then you just replace. Or you can get a simplified version of this entire function. I think this is more simplified. You can even get this part here. So if at all we are to consider this part, this is what we are expected to have. Since r is equals to 10, t r plus 1, which is equals to 20, choose r, and this is negative 1 to the power r, 2 to the power negative 1, negative r, sorry, and then which other part, and then x to the power 20 minus 2, x to the power 20 minus 2 r, and we found this value of r to be 10. So it is t, where there is r, put a 10, 10 plus 1, this is giving us 11, and this is going to be 20, choose r is 10, and then negative 1 to the power 10, 2 to the power negative 10, x to the power 20 minus 2, 10, like this. So when you look at this part here, before we could even go any further, this is 2010, negative 1 to the power even number, the outcome is going to be 1, and then 2 to the power 10, you can negative 10, you can find the value for it. And then this piece here, look at this part here, it is going to be x to the power 20 minus 20, which is 0. So it's x to the power 0. That's why we are saying it's independent of x. So this is what you are going to have at the end of the day. So just need to simplify this, and then you have that one. So the term independent of x is actually the 11th term, and the actual value for that 11th term is equals to this. So we can simplify this and say 20, choose 10, 20 choose 10, 20 choose 10 is equals to a lot of numbers, and then you multiply it to this, so you can finish it up. That's what we expected to do on that.